Another draft physics video presentation. There's the intro. Exciting. Yeah. Ooh, can't wait. Anyway, so another video where I play some other physicist, well, some real physicist, doing what they think is real physics, and I would argue it's just terrible physics, terrible science. It's all just, most of it's just made up. All the important parts, let's just say, the important parts are all just made up. And it's really not evidenced, and it's just a story they tell, and they include a bunch of what is just really fake evidence. They don't show you the real experiment, they don't show you really done, you don't see anything real, you just see them saying it happened. That's it. And there's a word for that. Shenanigans, garbage, lies, they're all not very good words. There's no good word for it. It's a bunch of propaganda and deception and fooling the masses because they're dumb suckers and they'll go for anything. Just about. As long as you say it and give them a lollipop and say how charming they are and how wonderful they smell and I love you so much and you're just so great. As long as you fucking, feed you people crap, you will eat it up. As long as I have a smiley little face and say pleasant little things about how wonderful everything is. But if I'm a little cranky, fuck you. You don't want to hear it. You don't want to hear about reality. You want a fable. You want somebody to tell you little bedtime stories. Oh, phew. The more I think about you people, the more I just, sickening. How just gullible and foolish and silly. You're just damn silly. Yeah, that's it. Fucking silly.
Quantum physics has a mystique of being complicated.
As a mystique of being complicated, it is complicated, frankly. I mean, the formulas have all kinds of silly symbols in them that are supposed to represent something, but the something they represent is a whole nother formula with a whole bunch of other asshole symbols in it. So, yeah, some of it is a little complicated, but the real dodge is they take group behavior, okay, and they try to sit there and connect it to individual behavior. So they end up just averaging. They have a herd of buffalo, and the average is a certain number of them will be 10 years old, and some will be 5 years old, and a certain number will be 3 years old, and those are just facts. And if you pick any one buffalo, he's going to be any one of those choices, but you can't say, oh, I know ahead of time what the buffalo is going to be. Yeah, so we don't know ahead of time what that particular buffalo is going to be, but we know that the buffalo herd has certain limitations, and they're turning that simple thing into something really complicated. So they're taking something simple, like dice are simple, right? I roll the dice, they hit things, they fly through the air, they turn, they twist, the air pressure, the humidity, all kinds of things decide how much they turn, how much they do all this stuff, because they're interacting with a bunch of forces. And if you could really see what's happening, if you could see the real sparks of the energy, if we could see the real energy, there's all kinds of sparking, all kinds of flying, and blah blah. All this stuff is happening. All kinds of heat distributions, all kinds of things. Like you're glowing with all of this stuff is hitting you. Radio waves flying into your cell phone, shit, all kinds of crap. It's jiggling your crap. You're full of this stuff. And we know though that there's nothing magic happening to the dice. There's no superpositions. There's no entanglements. There's no bullshit. It's all just sparking through all these different fields of mush that it has to go through, and all these things it bangs into, the other electrons and the atoms and how hard they are, and it's all going to decide whether it's a 7 or a 6 or a 5 or whatever the number's going to be. And they're all going to land flat, tend to land flat because they have the geometrics and the gravity. So we know there's forces controlling, and it's a real process. It's not some kind of magical process. So they're just taking something that simple and turning it into this crap. And it's that simple. They're saying there's a wave equation for those dice. They're saying those dice theoretically could be entangled. Those dice could be superimposed. Those dice could be all these things because they can mathematically do that. But it hasn't, you know that's not the truth. So why are you believing it when they talk about an electron? Why are you believing that somehow, yes, it's true that the smaller thing that we can't see is where all the magic is? Come on. Dupe. Dupe. Just change your name to Stupid Fucking Dupe. Okay? SFD. That's your initials now. Stupid Fucking Dupe. And then you can call yourself Obnoxious Trolling Stupid Fucking Dupe. Okay? But you just sit there and tell other people they're stupid, or they're Dunning-Kruger, or they don't even know how stupid they are, they're so stupid. No, you're the stupid dupes. And I've proved it. In playing this video, I will prove it again. That these fucking people who claim to be educated, okay, are just indoctrinated. I mean, it's just silly science. Shit.
Hard to understand. In fact, Richard Feynman, who won the Nobel Prize for his work on quantum electrodynamics, said,
so this guy has a very nice voice, he's very pleasant, blah 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 blah. It's called Domain of Science. I've probably played this video before. But you know, this is crap.
if you think you understand quantum physics, you don't understand quantum physics.
Right, because he saw the paradoxes in it, okay? He didn't like the wave-particle duality, clearly. He clearly stated, and photons are not waving, fellas. They're particles, they're clumps. You know, he saw the problems with this theory. And he said, yeah, of course, if somebody says they understand it, they're lying, because there's no way to understand it, because it's full of paradoxes. It's full of problems that have not been solved.
Which is kind of disheartening for us, because if he didn't understand it, what chance do the rest of us have? Fortunately...
La 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 la. See, again, this pretense that Feynman was some sort of brilliant person, when, yeah, he wasn't bad, he did some stuff, but I mean, it's not exactly, you know, there's no evidence that he was, you know, really wasn't. And then you see things like, you know, his whole, the whole Challenger investigation or whatever it was, you know, where he discovered that it was the you know, the O-rings. You know, that whole thing was a setup. A guy who worked for the company, you know, fed him the information so he would draw that conclusion, because he knew, but he couldn't say anything because he worked for the corporation that made the crap. You know, so he would have gotten in big trouble if he outed them. So he had to feed Feynman the truth in little pieces.
This quote is a little misleading. We do in fact understand quantum physics really well.
Oh, yeah, you don't. So again, all you understand is that, yes, groups, probability. This is all just probability theory. So there's a group activity, all right? A bunch of stuff does something, and it does stuff on average. The individual pieces do different things. The light coming out of the flashlight, for example, some of it goes longer distance than other little photons and all that kind of stuff. They're all a little bit different. They're all traveling different paths. So right there, they have to be a little bit different. And you're just taking averages. And then you're saying, well, what's the odds of when I go and pluck one of them out and look at it? What's the odds of it's going to be one of those things? That's all this is, okay? It's nothing more. It's, yes, it's something more, but it's not much more. It's only this little bit more. That's all it is. Everything they say about electrons, they could say about the dice. Every single thing. We just pretend we don't understand, okay, what happens to dice when they fly through the air or when they hit things. And so if we just pretend we don't understand any of that, all right, then all they're doing is saying exactly the same thing. They could do exactly the same formulas to the dice. They could do it to the roulette wheel. They could do it to every probabilistic activity that takes place and pretend, okay, that we don't know what the individuals are doing. The individuals are doing both things at once. The individuals are doing 10 things at once. They can make up any of that crap. All right? And it would work in a sense, but it doesn't work in any rational sense. And you can do probability statistics with different mathematics. You don't need wave functions to do the same analysis.
In fact, it's arguably the most successful scientific...
So again, this is just, you know, what is this hype from nowhere? The most successful theory in the history of mankind. It's just, no, analysis. Yes, it's very productive to analyze and figure out probabilities. But this math doesn't ever predict anything. It doesn't tell you ahead of time, okay, what the odds are of getting a 7. Okay, when you roll dice. Well, in a sense it does, because it just, you know, you tell it what the other faces on the dice are. I'm just saying, if you don't tell them what numbers are on the dice face, they're not going to be predicting anything. So it's just information in, information out. Yeah, you can do that, and you can do it other ways than quantum mechanics. So again, it's just wave equations.
Theory out there, and has let us invent technologies like computers.
So this is another one of the big lies. None of these things were invented by quantum mechanics. No theory invented these things. They didn't come up with the theory first and then invent it based on the theory. Okay, they already knew it happened. They already knew there was a phenomenon. Like back in the in the 30s, all right. They already had the transistor essentially. They already knew that they could create electricity by shining light on substances. So they already had it, and they just didn't know how to develop it. So there was no theory that made it possible. The discovery was, hey, somebody did an experiment and said, hey, look, electricity's coming out. That's what happened, okay? It wasn't quantum mechanics that invented any of this stuff. It's just such, I mean, you want to not call that a lie? I'm just saying it's so far from the truth to say that we need this wave theory to invent these things. That they didn't need.
Computers, digital cameras, LED screens, lasers, nuclear power plants.
I mean, I was alive, when they developed some of these things, and the silicon chip and the transistor and the CPU were all invented while I was alive, and I read some books on it at the time, and they didn't bother with any quantum mechanics to explain doping of the material to create negative ions versus positive ions. You didn't need quantum theory for any of that. So again, just more crap that somehow all of this stuff requires your wave theory. If I don't have your wave theory, I somehow can't figure any of this out. If I don't have Schrodinger's equation, I can't figure out how to do any of this stuff. When we already know that this was done because we found a phenomenon and we said, how can we turn this into something practical? It had nothing to do with theory.
You don't really want to build a nuclear power plant if you don't really understand how it works.
I mean, this is just so silly too. Nuclear power plants really have nothing to do with quantum mechanics. I mean, the fact is that we built the atomic bomb essentially without it. So, I mean, this is just more crap. That somehow we couldn't figure out that, oh yeah, if we take this uranium and if we purify it and then smash it into a small amount of space, we can accelerate its radioactive decay exponentially. And that's really all you're talking about, is creating radioactive decay in a quicker and quicker and quicker manner by doing certain things to synthesize, to play with radioactive materials. And so, I mean, it's a pretty simple process, frankly. You put the stuff close together, it gets really hot. You separate with some benign rods, and then you can control how hot it gets. You can expose it to itself more, or you can close, shadow it a little bit more, control exactly how much heat comes out. What do I need quantum mechanics for? It's a pretty simple equation. If it gets too hot, it all melts and goes right through your container. Gee, I don't need quantum mechanics to figure any of that out. I mean, again, this is all such goddamn hype. And the fact that you people let these people do this and you reward them, you applaud, oh, you're so brilliant, you're so smart, oh, thank you so much for, propagandizing, way overstating everything.
So quantum physics is the part of physics that describes the very smallest things in our universe. Molecules.
Yes, and that's what it should be. It should be a description, and the whole quantum word was applied initially for the idea that it comes in clumps. Okay, it's the clump word. That's what quantum is. Clump. You might as well just say clump physics. Okay, so again, and you turned it into waves. You destroyed all the quantum clumpiness of it, and that's what Feynman rejected. Even was the fact that you were trying to pretend that your wave was a clump. And you can't make a clump out of a wave.
Atoms, subatomic particles, things like that. And things down there don't quite work the same way that we used to up here.
Well, they do, but you have to just understand that they don't have the same road problems. They have to drive through gravity, and they don't have to do lots of things you have to do. And so in their world, there isn't all these things that might get in our way, which are like friction and such. They don't have to worry about how much all their molecules are moving, so they don't got heat problems. Things don't break into pieces. See, the clumps are indestructible clumps on their level. And the momentum is indestructible momentum in a sense. I mean, as I've pointed out with gravity, the momentum is destroyable in the sense that the simple argument is if I can force you to carry 50 pounds on your back, you're not going to walk as fast.
This is fascinating because you and everything around you is made from quantum physics.
Oh, he just did it again. I mean, no, it's not wave. It's all this wave mechanics is just rubbish. It's just probabilities you've applied to everything that we can see that don't have probabilities. I can see mountains. Okay, now there's a probability that all the mountains on Earth are all different sizes and made out of different stuff and all that kind of stuff. But the fact is, I can see that individual mountain. I can say things about it. Okay, that violates your Heisenberg nonsense, your notion that I can't know too much about that mountain. Well, I can know a lot about that mountain. So this is just rubbish.
And so this is really how the whole universe is actually working.
Yeah, it's not. So this is just so overstated. Like I said, it sounds like a pleasant guy, seems like a reasonable fellow, but that is just such a pile of crap. Okay, you can't live without Jesus. Jesus tells you how to live. He's the guide. He's the road. He's the way. Blah, 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 blah. This is just way, 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 way overstated.
Okay. I've drawn these protons, neutrons, and electrons as particles, but in quantum mechanics we really describe everything as waves.
I don't know why you drew the proton to look exactly like the electron. That's not too smart in a way, right? Because we know it behaves exactly the opposite. We already know the neutron isn't an elemental. It's, an electron and a proton. So why are we playing with that? We know this orbiting crap is irrational. So the only thing you have almost right is the molecule, except for the little yellow bar, because the yellow bar is supposed to represent something. Well, why don't you just show it's an electron, you're sharing it, or two electrons that you're sharing.
Waves. By the way, I'm using quantum physics and quantum mechanics interchangeably.
Yes, right. Blah 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 blah. Bullshit physics or garbage physics.
They're the same thing. So instead of an electron looking like this, it should look something like this. This is called a wave function.
Yeah, it means nothing, all right? Because, like I said, this is just them saying, okay, instead of seeing two dice, see two probability waves. The dice could be a 1, a 6, a 5, that's all they're doing here. They're just pretending, all right? For the sake of the argument, that's all that's taking place here. They're just saying, pretend that you don't see it and you know it's a 1. That's what they're saying to you.
But this wave function isn't a real physical wave like a wave on water or a sound wave. The quantum wave is an abstract mathematical description.
Right, of a group of individuals, and you can't assign who's who yet because you can't see them. So there's a Chinese guy, and there's a black guy and a white guy and a this guy and a that guy, okay, in a group, but you can't see well enough to see which one is which. So, you assign a probability. So what? What does it have to do with the truth? The truth is there is a white guy, there's a black guy, there's a Chinese guy. Why are you pretending, okay, that it's a wave? That each one of them is a wave of probability? They're not waves of probability. They're absolute factual things. And when an electron's flying through space, it's an actual thing. It's not some probability wave. It doesn't say I can be over here and I can be over here and I could be there and I could be where. I mean, there's no reason to believe that. There's no rational reason for you to believe dice don't know where they are in space. When you throw the dice, that they don't have a clear position in space and time and travel and the forces they're interacting with. And electrons have the same truth, and the only way they get away with this is we can't videotape the electron. We can't show you a slow motion tape of it just flying through space.
To get the real-world properties like position or momentum of an electron, we have to do mathematical operations on this wave function. So for the position,
you don't have to do any of that. You can just take averages, and so we've done that. We've measured things, taken the averages, and that tells us the answer. So you don't need any quantum mechanics to just do an experiment and see what you get as results. And that'll tell you what the probabilities are. Just like if you roll the dice enough times, you can know what the probabilities are. You don't need to do any mathematics at all. You can just write down a piece of paper, and it'll tell you all you need to know.
Take the amplitude and square it, which for this wave would look something like this.
So again, it's just probability math. You're just taking and square it like they're making that into some kind of special thing. It's just like taking line averages with Pythagorean math. That's the rule you do. You square to get the area, and that tells you the area of the hypotenuse. So I mean, that's all they're doing here. Okay, this is just some little Pythagorean type gimmick. So if you want to find the total, the mean, the average, then you just take the worst this line plus the minimum, the long line plus the minimum line, and that'll tell you the average line.
This gives us a thing called a probability distribution, which tells us that you're more likely to find the electron here than here. And when we actually measure where the electron is, an electron particle pops up somewhere within this area.
So again, you could do exactly the same thing with dice. Just put a blindfold on or whatever. We already have it on, frankly, right? We can't see the dice when they're in space. And so somebody could just make up this story. That, the dice are, who knows where they are, But once they land, we'll be able to retrace their path.
So with quantum physics, we don't know anything with infinite detail.
You don't know anything with any detail because you're taking group analysis, you're taking group behavior and then applying it to individuals. You're overtly doing that. That's what they're overtly doing. Okay, they're not doing anything else. They're just saying the group is the individuals.
We can only predict probabilities that things will happen. And it looks like this is a fundamental feature of the universe.
No, I mean, it's just so silly, right? So again, you wouldn't fall for this if he was saying this about rolling dice. You just wouldn't fall for it.
Which was quite a departure from the clockwork deterministic universe in classical physics, the kind of thing Newton derived.
Again, Newton didn't even suppose about some of these forces and how they interacted. So again, just putting thoughts in Newton's head, okay, about any clockwork universe or any of that stuff. I don't even think they've drawn any of those conclusions. I mean, Newton was pretty much a religious kook. So why are you assuming that he had some clockwork notion, or that he understood determinism, or that he understood there wasn't any such thing as free will, or any of the other implications of the fact that the universe doesn't have any spooky action in it? There's no spooks running around inside your brain. If you have any talents, you earn them, so to speak. Okay, you had to practice the piano to know how to play the piano. There was no freedom to quantum mechanically do it.
This wave function model predicts what subatomic particles will do incredibly well.
So again, this is just so silly. Yes, if I watch the roulette wheel and write down what it does, I can predict what's going to happen pretty reliably. I'll predict, well, one of those numbers is going to pop up. Yep, it's going to be a 1, it's a 00 to, 32 or whatever. Yep, I predicted it. Aren't I brilliant? Because I watched it. I looked at the wheel and said, yeah, there's only 32 numbers. 47 isn't coming up. Guarantee it.
But weirdly, we've got no idea if this wave function is literally real or not.
So we do have a way of knowing, because you just made the whole fucking thing up. We can go look at who wrote the story, okay? That's one way of knowing. The other way of knowing is it's ridiculous theory. It's preposterous. So I know as soon as somebody tells me there's a gingerbread land, okay, and a witch has a gingerbread house, and blah, oh, fuck you. We're done. 3 bears and they eat porridge and sit in chairs and shit. Oh, please, we're done.
No one's ever seen a quantum wave because whenever we measure an electron, all we ever see is a point-like electron particle.
What we see is the fact that, yes, we're looking at an individual now instead of a group. And the individual will be an individual. He'll have all of those characteristics of the individual. And he won't have the characteristics of the guy over there, or the guy over there, or the guy up there. No, he'll have his characteristics.
Cool. So there's like this hidden quantum realm where the waves exist, and then the world we can see, which is where all the waves have turned into particles.
Oh, so again, what a bizarre thing to say even. It's just so bizarre. I don't even know why like I said, why does this even give it any credibility? The waves turn into particles? Oh, please. On what level do they do that? I mean, where's the certain size you get where your wave turns into an actual particle? How big do you have to be for that to happen?
And the barrier between these is a measurement. We say that a measurement collapses the wave function.
Yeah, you say. So again, that's just more crap, right? We know a measurement's taking place all the time. Every time a piece of cell phone energy hits me, I've been measured. Every single time the gravity works on me, I'm measured. Every time anything works on me, I'm measured. Every single photon that hits me, measuring. How do I have any time to do any of this spooky bullshit? And so again, it's just completely unnecessary. It's silly. Why are you believing it?
But we don't actually have any physics to describe how the wave collapses.
Yeah, you don't have any physics to make, and you don't have any reasoning to make it at all sensible to say that something could possibly travel through any part of the universe for any amount of time without being measured, because there's so much forces affecting things. There's so much stuff in the air, so to speak. It's so full of measuring devices that you can't go anywhere without hitting a ruler. Every everything that ever happens to something, it's getting rulered. Electrons can't just, I'm just flying through space, being not being affected by anything. No, they're being affected all the time, constantly being affected.
This is a gap in our knowledge that we've dubbed the measurement problem, and this is one of the things that Feynman was referring to with his quote.
So you're basically confirming what he said, so you really don't know shit because you don't know the most fundamental aspect of your silly theory, which is somehow all the spookiness goes away. the spooky measurement to spooky way, or whatever. The way you take away the spookiness is to, fill the room full of fog, and now you can see the light beams. Yeah.
Another confusing thing is how exactly to picture an electron. It seems to be a wave until you measure it, and then it's a particle. So what actually is it?
It's obviously a thing, so we can say that much about it, because it has these properties. You can't have properties if you're not a thing. And it certainly has this property called charge, and so you have to account for that one. That's a pretty big one, pretty substantial one. That's the major thing it's doing, is being charged, which means it'll do exactly the opposite. And if I put it in the same place in the universe, and a proton does this, the electron's going to do that. Yeah, they're going to do exactly the opposite thing in the exact opposite spaces.
This is known as particle wave
I mean, in the exact same space, they'll do exactly the opposite thing.
duality, and here's an example of it in action, the famous double slit experiment.
So, and this is just so bad, again, just made up all this crap. It's just all made up, doesn't have anything to do with the real experiment, doesn't have anything to do with the real pattern, doesn't have anything to do with what we already know about the pattern. So it's just a big pile of stinky poo.
Imagine spraying a paintball gun at a wall with two openings in it. You'd expect to see two...
Right, now if you sent those paintballs at a frequency, right? So that, but we already know that's the rational thing to do, is to figure out that light's a frequency, right? So I should send them like dot 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 dot, in a row. And then I should realize that some of them are going to hit these edges here, and they're going to spiral off differently, okay, and change their phase by doing that. They're going to travel different distances, and they might even be going different speeds, which a photon really won't do. But anyway, let's just talk about that. And the fact is in some places the phases are going to match. So there's going to be paintballs over here, and paintballs over here, and paintballs over here. And if I did shoot them at a frequency to start with, I could rebuild the frequency in these different places. Now the paintballs that go straight through, I'm not going to have to rebuild their frequency because they went straight through. So I'm going to see more light in there. But obviously this is a tiny, tiny space here, and this is a big, giant space over here. So even this doesn't make any sense, because these two bars aren't going to be spread out. No, they're going to be 1 millimeter apart. I'm not going to be able to see 1 millimeter. So that's not going to work, is it? No, it's not going to work. I'm going to see a blob of light.
Columns of paint go through and hit the wall behind. But if you shrink this all down to the size of electrons, you see something quite...
So again, this experiment never took place. You don't see it. They never did it. It can't even be done theoretically. The electron's velocity is what they call its frequency. So they've turned the electron's momentum into a frequency and said the electron has a frequency. Well, the frequency of the electron is trillihertz, okay? It's like way the frig tiny. And the whole idea of the slit experiment is you can't have too many wavelengths in the distance. So if the width of the slits, I could use my little, come on, move it. Yeah, there you go. All right. If the width of these slits, okay, if I was to do this in light experiment, I can't make this with, 500 nanometer. I mean, 500 times the wavelength of the light. If I made it 500 times the wavelength of the light, little bars get too small to see. It's probably 500 is okay, but it can't be 1,000. Right? So the electron has a frequency, especially when they shoot one, the momentum is turned into a frequency. Insanely high frequency. You have to make this slit so narrow to match its frequency that it'd be smaller than the actual electron, frankly. You're not going to get your electron through it. If you do it with buckyballs, their frequency is gazillion trillihertz. Okay, I mean, it's an insanely high frequency. You can't make a slit small enough because you couldn't get the buckyballs through the slit. It would be so tiny. So the whole theory falls right apart. And we know in light, there's a complete proportional relationship between the width of these slits, the distance between these surfaces, actually. The distance between these surfaces will tell you exactly how many bars you're going to get on that surface. It'll tell you exactly how many frequencies, places where there's a in-phase and out-of-phase possibility. So they're not even smart enough to use their own probability math to understand that there's only a certain number of possible locations on the surface where there can be constructive or destructive interference. There's not an infinite number. This projecting it on a flat plane is a complete deception. There's no infinite number. They get wider and wider and fatter as you go further and further away, and they get more and more distorted. Their math doesn't predict any of that because they don't have to account for it. Because they don't do this experiment any kind of real way, in any kind of analytical way. They just do it in a metaphorical way. And the very fact that he made up this lie, that this experiment, he is arguing as if this experiment was done and they saw something. The argument clearly is that it was never done, and it was never done by the same rules applied to photons in the experiment. So it has nothing to do with it. It never was done. It's a theoretically impossible experiment in the sense you can't make the slits narrow enough. We can't manufacture slits narrow enough to confine an electron, to limit the number of frequencies the electron, the slit has to be under 1,000 or whatever the number would be, wavelengths wide. And at the wavelength of the electron, that means it's less than an atom or something. We can't make a slit that small. So this whole thing is a lie. It just is an insane... it's a lie to say we did the experiment. It's a lie to imply what the outcome... I mean, the whole thing is just so bad. This is terrible physics. He should have stuck to the light experiment, but he didn't want to do that because he knows, then I have to explain those two patterns, and I can't do it. So he just copped the fuck out.
Different. You can fire one electron at a time at the slits, and they appear on the back wall.
Like they can do this anyway, right? So again, this whole thing, they can't do it with a bunch of electrons, let alone a single electron at a time. It's just a pile of crap. The only experiment they can do is they can shoot stuff at a material and get reflections off of it. It's not the double slit experiment. Not even close.
But as they build up over time, you get a whole pattern of stripes instead of just two bands.
And the stripes don't match the stripes you get in the double slit experiment. So again, how can you say it's the same phenomenon when they don't even match? The double slit pattern in light clearly is two patterns. Why aren't there two patterns here? If you did the experiment. Like I said, they didn't do this experiment. It's never been done.
This pattern of stripes called an interference pattern, something you only see with waves.
And it certainly can't be done consistent with Broglie frequency dynamics. You certainly can't do it and use the same math, because it just can't work.
The idea is that it's the electron wave that goes through both slits at the same time, and then the waves from each slit overlap with each.
Right, so we're back to this silly Young diagram that doesn't work in light. It won't produce the wave going through the middle of the slit. This doesn't work. That's not the math that works. The math that works is the surfaces are the point sources. So again, this is just a lie. I mean, you can't call it anything else, right? I mean, it's overtly an experiment. It hasn't been done. He has no data to back this up with. It's just a fucking story they tell about the magical slit experiments. They're not real experiments. He's showing you fake experiments. This isn't any real data. This is fake data because it doesn't work. It mathematically fails. What he's drawing doesn't work.
Each other. And where the waves add together, you've got a high probability of the electron popping up at the wall. But where the waves cancel out, the probability is very low.
Yeah, well, again, this is kind of silly where they cancels out. It doesn't have anything to do with the probability. Obviously, the probability is there's more light in the middle than there is on the edges. So whatever's happening to these photons, clearly more of them are going straight than going crooked. That's something you can draw a conclusion about. Fewer of them go at 20 degrees or 10 degrees or 30 degrees than go at 90 degrees, from the plane of the slits. Clearly.
So actually on the back wall, the highest probability of finding the electron is in the middle of the slits. And then it goes down and then up again and down and up again.
You're right. So you're to believe, okay, that if you did this with some other mechanical thing, that you're supposed to believe, that this has something to do with not individual electrons going to different places, but somehow every single electron, okay, went to all these locations, and then only when you looked at them did they stand in one place. When the simple conclusion is, oh no, one electron went over there, and then one electron went over there, and one electron went over there, and that's exactly how they receive them, as little dots on the film, and that's exactly what happened. They all took different paths. And why did they take a different path? Because some of them went right through the middle and some of them went right next to the surface. That's why they took a different path, obviously. They obviously all didn't go through the same space. So they all got interacted with different things, and that's why they did different things in the outcome. The probability is easy to understand. Just like you can understand, the more surfaces the dice hits, the more variables I'm introducing, the more random, quote unquote, the outcome will be.
And this is the interference pattern. So when you fire one electron after another, they follow this probability distribution.
No, they all follow a path, and it's either close to the surface or it isn't close to the surface, and that'll decide where the piece is going. And with photons, obviously you're just recombining pieces, back in phase. And there's places where they won't be in phase, so the pieces can't be a photon anymore because the frequency's been broken. If they're out of phase, there's no frequency. There's no frequency consistent with the light you shot. So you won't see that.
This interference pattern starts building up, and that's exactly what we see in experiments.
So again, he says it again. It's exactly what we see in experiments, as if they've done the experiment. They haven't done the experiment. There's no such experiment. You can't do the experiment. It's theoretically impossible to do the experiment, but just keep pretending that's what you're doing. Okay, fine. And I'm supposed to say this is really good science. This is what intelligent people should do with their brains, is propagandize for a religion. This is quantum religion. This silly notion that things aren't things, that they don't know what they are, they don't know where they are, it's all magical somehow, we're all in a magic verse. I mean, this is a religion.
So this shows that electrons behave like waves in this experiment.
No, it doesn't. Okay, the math doesn't work for a wave. The wave has to go through the middle. The wave center would be in the middle of the slit. Well, that math doesn't work. Put the wave center right on the surface. That's the wave you've got to create. Now explain how you've got a wave function created right on the surface. Why is there a wave function on the edge of the surface? Why is that the center of your wave function? How does that happen? Why do surfaces seem to be causing the phenomenon? That's why they can make two waves out of the single slit, by the way, is because the single slit has two surfaces. Count the surfaces. That'll describe the experiment. You have the two surface experiment, right? This way or, this way, two surfaces, right? Or you have the four surface experiment where you have, inside and then you have the outside surfaces. That's the real truth.
The question is, what actually happens to this spread out electron wave when you do it?
So again, the spread out electron wave, they know that they're not spread out waves, right? So again, Feynman would say, no. Okay, they are electrons. And, Feynman's cop-out will be, well, the universe is just fucked up and it just whacks out. It just randomizes. So when it goes through the slit, it randomizes. That's his answer to the question. He doesn't bother with this wave crap because he knows the wave crap doesn't work. He's probably one of the only physicists who sat there and actually said, hey, this math doesn't work, so why do we keep drawing this fake math? Because it doesn't work. The fake math won't get you the right answer. Okay, this little wave in the center of the opening, now that ain't going to work. You got to put it on top of the edge of this slit, and then you got to put 4 waves in here.
Measurement. It seems like it goes from this spread out wave to this localized particle. But like
it seems like. So again, we could just, it's the, and they just want to believe. That's the only thing you can. It seems like coincidences can be so bizarre that just, it seems like there must have been a designer for that circumstance, because that's just too frickin' weird, right? I mean, you bang into a guy, you have a car accident, and the guy has the same name as you or some other kind of crazy shit. You're just like, somebody must be doing this. This is too funny a joke. But we know, no, that's the nature of coincidences. So this seems like thing is just you got to be real careful to evade this kind of seems like, it seems so mysterious. Well, it only seems mysterious because you really didn't think about it, and you really didn't analyze it, and you really didn't do the experiments, and you really didn't pay any goddamn attention. The Young experiment was wrong when Young introduced it. It was already wrong. The math already didn't work. Okay, it already didn't predict where the bars of light were. It was already wrong. And you're sitting there still iconizing it and saying, that's where we got our truth from. It was already wrong.
Said there's nothing in quantum mechanics that tells us how the wave function collapses. And this is not only true for electrons, but everything in the universe.
Yeah, so this whole, how do you collapse something that's in more than one place in the first place? That doesn't even make any sense. How do I collapse it? How do I hit it with something and then collapse it when it's not in one place? Huh? What? Yeah, how do I do that?
So this double slit experiment has huge consequences for our model of the universe.
And how does the thing that's going to measure it not already have its own problem of being in more than one place, right? I mean, the thing you're using to measure it is going to be one of these quantum objects, one of these little things. And this little thing is going to have the same problem of, I don't know where I am. So you're going to measure a thing that doesn't know where it is with something that doesn't know where it is. That really isn't going to work at all, is it?
And it was very surprising the first time it was done. Physicists are still grappling with this question today.
No, you're not grappling with anything. You're not paying any attention. You're not really looking at the details. Again, it's clearly my skepticism motivated me, okay? I hear your story and I say, this is just religion. This is just wacky, silly theory. Doesn't make any sense, doesn't fit any kind of continuity here at all. It just makes the whole universe into a mess. A preposterously silly, stupid mess. I'm saying, well, why? Einstein was the only one who protested. I mean, it's just kind of amazing that all of you just said, no, we'll go anti-Einstein and we won't protest and we won't try to find a better answer than this silly theory, this preposterously silly theory, kind of proposed by Bohr, a guy who was clearly biased in terms of religious notions of reality. That it was all about our consciousness and our humanness, that the universe is some sort of play that we're writing. La 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 la. I mean, it's clearly got religion as an origin.
And I've come up with many interpretations of quantum mechanics to try and explain these results and explain how reality...
And all of them are based on, let's accept these silly premises, so let's write a silly theory that makes gingerbread, waterproof. So we have to make the gingerbread waterproof, and we have to make sure the bugs don't eat it, and we have to do this, and we have to... So they come up with all these wacky theories that have to fit all these wacky conditions that they've imposed by this wacky, wavy bullshit theory.
Actually works. Okay, let's go back to the wave function. We can now use this picture to explain other features of quantum physics that you may have heard about.
Right, so now they'll pretend all of these things, these properties, are the same. So spin is the same as polarization, is the same as color, is the same as blah. And that's what they did. Okay, they clearly do it. So all their entanglement experiments are really about light and light polarization, and they think it's something to do with spin. So they pretend that photons are spinning because they're polarized, somehow they associate polarization with spin, and then say they're doing a spin experiment when they're really just doing a polarization experiment. I mean, it's that bad. It's so corrupt, so fake and phony.
So this is just one possible wave function for an electron, but there's many others, like this one for instance. This says that the electron has a probability of being over here and a probability of being over here, and very little probability of being in the middle. This is...
Oh, how exciting. Yeah, but again, something has to be producing the electron, right? So obviously whatever's producing it has left and right choices. I mean, that's the only way you're going to get an electron with this wave function is you have to create a circumstance. So if I wanted to change the wave function for the probability of flipping a coin, right, all I do is add more flips, right? If I just flip it really lightly, I'll just flip it over once, and I'll always get the same answer, right? So I can change the probability curve for the group by just saying, well, if I do it this way, heads, I put it on heads, and then I just flip it when it goes flips to tails, and I'll get 100% tails, 100%. So then I'll have a wave function that's all just one lump. But then if I give it a little extra, then I can put in a little bit of doubt about whether it's going to be heads or tails. And now that one little introduction can change the two choices. But, this is just, again, if they applied any of this crap to what we know in the real world happens, difference between groups and individuals. And that's all that this is. They're applying group theory and saying it has something to do with individual theory. And they're not the same thing at all.
Perfectly allowable in quantum physics, and this is where the phrase things can be in two places at once comes from. This is known as superposition, which comes from the fact that this wave can be made by adding, or superimposing, these two waves.
So again, this is another complete breaking of the meaning of words, right? Because the original purpose of the word superposition was to argue about fields, like gravity, and the fact that the fields just add. All you do is add up. You introduce some new gravitational object, you just add the gravity that it's imposing to all the other things, whatever's being they're imposed on. So it would be just like it's something firing bullets or something like a light bulb, and you're just doing the inverse of that, with gravity. So it's the same thing. Obviously, when you introduce another light bulb, you just introduce another source of photons, and you just add the photons to the field, and that's it. So there is no interaction between the photons. There's only photons received on a surface, and you're just measuring how much light hits surfaces. And that's what superposition originally was for, was describing the fact that the fields can't interact with each other. They can only add to each other.
The word superposition just means the adding together of waves.
Yeah, so it had nothing to do with adding waves, so that's this new bullshitty thing. So all you're doing is you're just saying that, yes, if I turn on one flashlight and then I turn on another flashlight, the flashlights don't combine, they don't do anything. The individual flashlight is producing real photons, they all go where they're going, and it doesn't matter whether I turn the B flashlight on first or the A flashlight, doesn't matter what order, doesn't matter any of this stuff. It just matters, do I have an A flashlight on and a B flashlight on?
We already saw this in the double slit experiment.
So you didn't see any such thing. There's no seeing of any superposition. There's no seeing of any of this crap. It completely can be explained as a nice mechanical process. You have absolutely no obligation to believe this crap at all. And it's all being hyped as if they did experiments they never did, and that the results are what they say they are. Again, they keep drawing waves coming out of these two slits when the mathematics clearly says the only way you're going to get the right answer is you got to have 4 waves, and they have to be right on the surface. The center of the wave has to be right on the surface. Isn't that too bizarrely unwave-like? That's exactly what you would expect from a particle theory, not what you would expect from a wave theory.
And it's not really a very special phenomenon. You can even see superposition by dropping 2 pebbles into a pond where the ripples overlap. Now for entanglement.
Now, so he just implies like you can see superposition. No, all you see is a simple process that the two things do their own thing. And in places they can be doing the same thing together, and other places they're doing opposite things. That's all. There's no superposition. There's no the wave is the thing is in two places at once. The water molecules don't know where they are anymore, and they're different places. No, the water molecules are doing exactly what they've been told to by the force you applied. They're traveling direct and obvious paths. The water molecules have no confusion whatsoever. So again, this whole idea that that's an analogy for their super wacky dumbass theory, there's no analogy between water. Again, in water waves, there is no interference pattern in a single slit. Because in water waves, it's not about the surfaces, it's about the opening. In water waves, the point source is the opening, the center of the opening. That's the point source. That's where the wave forms, as on that center. Clearly in light, it doesn't form there. No consistency at all. So they keep applying a seems like argument. Oh, it's just like. You can see it. No, it's nothing like. It's not true. It's not accurate. It's not factual. The statements this guy is making are not facts.
Let's say two electron waves meet. Their waves interfere with each other and become mixed up. This means that
So this isn't about two waves meeting, right? This is about, now he's talking about photon experiments, right? So he keeps changing the ball field he's playing on to create this confusion. And as I've pointed out, this confusion can be easily understood. This is the entanglement issue, right? So you could clearly understand, okay, I move my hand towards you. It creates more energy towards you, okay? There's more photons reflecting, more stuff is happening. My hand pushes more energy into you, essentially. And my hand, from my perspective, gets smaller and is disappearing. If I could move my hand at the speed of light, my hand disappears when I move it away from me. It really starts to appear to you really, really opaque, really loud. And then when I move it away from you, if I move it at the speed of light, you can't see my hand anymore. It's completely invisible, right? Now, isn't that the same thing as a wave? Now, isn't that the same thing as saying, here, the pattern's on, and I move it away, the pattern's off. The pattern's on, the pattern's off. I send a bunch of photons, I send no photons for a period of time. The whole time I'm moving away, no photons are coming towards you. I move my hand towards, photons are coming towards you. Well, what's happening on the other side of my hand is exactly the opposite. The two waves are completely out of phase with each other. When one side is saying on, the other side is saying off. When this side sees on, this side sees off. When this side sees off, this side sees on. So essentially, you could argue there's two photons being created that are exactly at 180 degrees out of phase. If you were going to force it to be a wave, I'm arguing it's a clump. You have clump, then you have no clump, and then you have clump, and then you have no clump, and that's what's creating the frequency. So it's very simple, all right? There's no entanglement here. There's no mysteries here. There's just the fact that you're creating two signals, and the one direction you're sending on, off, on, off, on, off, and the other way you're sending off, on, off, on, off, on, off, on. And it's that simple. No entanglement. You've just created a right-hand glove and a left-hand glove.
Mathematically, we now have one wave function that describes everything about both electrons, and they're inextricably linked, even if they move far away from each other.
So you have a wave function that's absolutely useless because it just says it's either heads or tails. That's their wave function. Well, it's either the right-hand glove is over here, or the left-hand glove is over there, and the right-hand glove is over here, the left-hand glove is over here. That's all they have as a wave function. Okay, so you just mentioned it as if you have some mysterious thing. No, you're just saying I don't know which way the left one went, and I don't know which one went on, off, or which one went off, on, off, on.
A measurement on one of the particles, like measuring if it's spin up or down, is now correlated with a measurement on the other.
Yes, for the obvious reason, okay, that if you're going to receive one of the signals, it's going to be on, off, and the other signal then will have to be off, on, off, on. Yes, if you find the right-hand glove, you'll know the left-hand glove's over there.
Even if they move billions of miles away.
So again, this is just made up. There's no real evidence of it. There's no proof of it. There's no experiment that demonstrates it. It's just a big pile of made-up assumption. It's all based on what they assume is happening. They don't understand polarization of light. They don't understand how it works at all, really. They have no rational theory of it, and yet they're saying these light polarization experiments prove that those two gloves aren't right and left-hand gloves. that the photons weren't created as the rational way I described. No, they were created in some irrational way where the two photons came off of an electron or a group of atoms. The photon was created, and they're really not doing that simple thing I was saying, that obviously if I'm yanging this way, I'm yinning that way. So that obvious explanation, they're going to turn into, no, it yins and yangs in some random way, but the two particles are either both, they're yin-yang, but they don't have any identity until you look at one of them, and then they decide whether they're yin or yang. I mean, what a pile of crap.
Einstein was very uncomfortable with this idea because if you measure one of the particles here...
So this is even saying it all wrong. Einstein thought up the idea as a thought experiment. His basic argument was, yes, the photons are being created inversely. They're as right and left-hand gloves. And he was just making the point that your physics doesn't make much sense because you're saying I can't know anything about this thing. Well, all I have to do is go find the right-hand glove and I know that guy's a left-hander. All right, so that's it. So Einstein was just pointing out how your Heisenberg notions and your notions of I can't know anything about any other thing in the universe are kind of bullshit because all I have to do is find the right-hand glove and I know this one's a left-hand glove. That's what Einstein was saying. And he was using that as a thought experiment to say that's why your quantum mechanics is broken and incomplete. And that's what he said. He says it's broken and incomplete. All right? That was the argument. He's making arguments about incompleteness of your theory. And they turn it into Einstein somehow invented entanglement. No, he didn't.
Yeah. You instantaneously know what the other will be, even if it's billions of miles away. And that's got a sort of whiff of faster-than-light communication, which is not allowed by the theory of relativity. But it turns out you can't actually use this to communicate information, because the measurements...
Yes, you can't use right-hand and left-hand gloves either. You can't use it to communicate information, but that doesn't change the fact that it's true. It doesn't change the fact that there is no law that we can't know. It's just hard to know. Okay, but they're really tiny things, okay? We just can't videotape them. We can't track them. We can't put little trackers on them that bleep. We can't do all this stuff that we do to find stuff and do all this stuff. So, yeah, but here's a little trick we can use to gain some information.
Give you random results. But the fact that they are correlated means that somehow there is a link that stretches over that distance. This is called non-locality. Quantum tunneling.
So, and again, Einstein was correctly saying bullshit. Prove it. Show me. And here's a rational argument that's going to explain why this doesn't work. And so then they had to say things like, oh, you think the moon's not there when I'm not looking? And then they had to do the Schrodinger cat thing. They had to do all these preposterous things to try to point out how silly this is. And instead of conceding, oh yeah, we are really in silly land, they doubled down. And just said, yeah, isn't that amazing? The cat isn't alive and it isn't dead. Isn't that amazing? No, it's stupid.
Quantum tunneling is where particles have a probability of moving through barriers, essentially allowing things like electrons to pass through walls. When a wave function meets a barrier, it decays...
So this is just more crap. Okay, and that's all it is crap. And this is all based on this, how light is slowed down when it goes through materials. And they're saying that, oh, there's places where the light's still going the speed of light. Well, of course, it's going the speed of light the whole fucking time is the point. The force is always going the speed of light. And so all you can do is somehow make it more efficient so it doesn't get slowed down as much, which means it doesn't go crooked as much, which means it travels a straighter path through the electrons, for example, as electricity. Then it goes very fast. Okay, electricity travels through wires almost the speed of light, right? So, I mean, it's, you can make it go very fast. Fiber optic cables have kind of a disadvantage because the whole point is to reflect the light, to bounce it off the sides of the fiber. So obviously the light's not going to go the speed of light in a fiber optic cable because it's got to go a lot of more distance. Yeah, and that's all this is about. So they see these variable differences that they can control some of this stuff, and then they just make up a story about how it went in one side and popped out of the other side instantaneously. Or faster than the speed of light. Well, no, it's faster than the speed of light in glass, but it's not faster than the speed of light in the space, and the speed of light never really changes anyway, and you have to kind of understand that the reason why the light's taking time to get through the substance is because it's got to move electrons while it's in the substance. That's what it's actually doing. It's moving electrons, and it's slowing it the fuck down because it's got to move electrons.
It's exponentially inside the barrier, but if the barrier is narrow enough, the wave function will still exist on the other side, meaning that there's a probability of the particle being found there when a measurement is made. In fact, the only reason you're alive is because of...
Well, I mean, this is just so stupid. The only reason why you're alive, I mean, it's just such a stupid statement. The only reason why the universe is a universe, and this... No. You could change lots of rules, change lots of things, and everything would still figure a way to work. So, I mean, this is just such a pile of crap.
Quantum tunneling in the sun, which makes...
So again, they're totally unnecessary. All you do is have a simple phenomenon. There's a certain amount of energy required, a certain unlikelihood of two hydrogen atoms doing their deuterium thing, and then that fusing into helium. And so the process has this unlikely event in it, this certain improbable event. Doesn't mean anything. Yeah, so what? It's an improbable event. So what? Radioactive decay is an improbable event for some substances. I mean, once every 10,000 years when the thing it happens. Just imagine that, that's the real probability. And so you need 10,000 of them to have one a year. And then you need like 100 million of them to have one every 3 hours. And then you need, but I'm just saying, but we know there's a circumstance that's causing it. As Newton would say, you'd have to be a fucking idiot, a fucking fool, a fucking moron to think it's nothing that's causing it. There's obviously a something doing it.
The sun shine. Protons normally repel each other, but they've got a small probability of quantum tunneling into each other, which is what turns hydrogen into helium and releases fusion energy.
Right, so you're just saying there's events that take place that are simultaneous, or they happen in a certain resonant frequency, or like lightning strikes at the same place, and it's just not likely. But if you have enough little of those, you have enough little atoms inside of the sun, it doesn't matter how unlikely it is, because you have so many probabilities. You're rolling the dice so many times that yes, you can get 4 or 5 ones.
All life exists on Earth because of energy from the sun.
Right, and so isn't this just aggrandizing? We've proven beyond any reasonable doubt that a magical event has to take place in the sun, therefore your whole life is magical. Oh, fuck. Sorry, I mean, this is just such religion.
Except for life around hydrothermal vents. Now onto the Heisenberg uncertainty principle. I said at the beginning that this wave function contains all of the information like position and momentum of the electron. We just have to do some maths on it.
Ugh, roof. It doesn't have any of those things, right? The only way they can know those things is they have to go out and find those facts. So again, they sit there and show you an equation, the Schrodinger equation with a little forky thing. A little forky thing means, oh, I've just found out all the information about what the field is doing all around it. So I know everything about what's happening around the electron, and therefore now I can predict where the electron's going tomorrow. Well, of course you can. I can do that with everything. If I know everything about it, then I can know exactly what it's going to do. So the equation isn't some simple little wave like this. No, the equation is a bunch of details about everything around what the entire universe is doing around that electron. That's the big lie of this. We can predict. You can't predict anything without a bunch of facts being provided.
The position is given by the amplitude or height of the wave, and the momentum is given by the wavelength of the wave. But for this specific wave, the position gives us a probability.
So again, there's no this whole de Broglie bullshit that everything has a frequency. I mean, by their bullshit, a car going down the street has a frequency of 1 Google plexi times 10 to the 4 millionth. It has some preposterously insane frequency.
Distribution, so we don't know exactly where the electron is. Also, there's an uncertainty in the momentum because this wave is made of many different wavelengths. But we can reduce that uncertainty. Let's have a wave that only has one wavelength, so a sine wave. Now we know the momentum exactly because the wave...
So, and again, this whole sine wave dependency, and there's no evidence of it in their theory. The photon experiment and the two-slit experiment, by their theory, is supposed to produce gradually on and gradually off light. It doesn't do that. It creates bars of light, clumpy bars of light. So again, more failure of their analysis to be anywhere near the truth, anywhere near the real experimental results. They just couldn't care less.
Length as a single value. But look at the position. There's an equal probability of the electron being found anywhere in the universe. Okay, let's do the opposite. Let's make a wave that has only one position. Now we know exactly where the electron is, but what's the wavelength of this wave? Now the wavelength is very uncertain. Basically, only a sine wave gives you a precise momentum.
Well, I guess you just drew this with a certain thickness, so I guess we'd say that's the wavelength, is however thick it is. Huh? Yeah, but whatever.
And any wave that isn't a perfect sine wave, you have to build out of multiple different sine waves. In each of those multiple different sine waves, it's got a different wavelength. And hence,
so this is all based on the fact that you need a certain amount of energy to kick electrons out of atoms, and that you could call it a resonant frequency. You need a certain amount of hitting rate for you to push an electron out of pressure. So depending on where the electron is, it's being held by a different amount of pressure. And what you're really just saying is how hard do I have to hit it to knock it out of that pressure? That is, how fast do I have to hit it? And that's the only component frequency provides. So it's just kind of a tipping point argument. You're hitting an electron with some energy. The electron is going to go back to where it was, okay, because that's what electrons do. They're in tension, so they're like they're on rubber bands. They're going to move back because the field between the charges is going to force them to move back. But if you hit them, and then you hit them again before they move back, well, you're hitting them from a new position. You can move them further out. And the real question is, if I can make that frequency high enough, I'll kick the electron out. And that's the photoelectric effect. All right, and that's an indication of where photons get their frequency from, is about where did you move the electron? How far did you move it, and how fast does it move when you move it? How fast does the electron move from one place to another? How fast does it move from high tension to a lower tension? And obviously it would move faster from high tension to lower tension, and then if I go much lower, they'll move slower into the lower tension because the spring is less of a spring. So it really just has to do with how fast the electron moves, because that'll tell you what the frequency of the energy the electron's producing. Just like when I'm moving my hand in front of you, you can imagine, all right, that there's a real amount of energy that I'm forcing. If there was energy hitting this is being made out of reflected light. You can understand that if I push that reflected light, I'm going to blue shift it. I'm going to take that energy and I'm going to push more of it towards you faster in a shorter period of time. And that's what the electron is doing, the very same thing. So that's how the electron is controlling the frequency of light. So yes, all of these little factors add in to understanding that there's resonant phenomenon. But resonant phenomenon doesn't mean that the light itself has more energy, that the little bits have more energy, that there's some kind of more energy about frequency. The only way frequency makes more energy is the higher the frequency, the smaller the polarization, which means all of the energy hits a smaller surface. And obviously, the closer I have the clumps, the more clumps can fit in the same amount of time. But that's it. The clumps themselves don't have any more energy.
you have a range of the possible different values of momentum for the particle. This is Heisenberg's uncertainty principle. You can only know certain things precisely, but not...
Right, and it's a principle, and it's not called a law because they haven't gone that far yet to say it's the Holy Ghost law, right? They're kind of uncertain about the Holy Ghost law, but they want to call it a law. They want to make it real. They want to force you to believe it, but it's crap. It's just a statement that doesn't mean anything, just like Einstein's equivalency principle. It's just wishful thinking. It doesn't work that way. The fact is we can't see the damn things, and that's the only fact that makes it uncertain. It's just the fact that our vision has limitations. And that's it. There's no certainty in its actual reality.
Not everything. Either you've got a definite value of momentum, and don't know anything about position, or you know the position very well but don't know anything about the momentum.
And this is just an observational problem. Both the momentum and the position are fixed. Both of them are real. And there's nothing, no physics breaks if you accept that reality. You're not stuck with a universe that doesn't work. You're stuck with one that works fucking better.
Or you're in some intermediate state. And this isn't a limit of our measuring apparatus.
He says it, okay? He just said this isn't a limit of our measuring apparatus. It clearly is a limit of our measuring apparatus. We clearly can't see the things. We clearly can't know any of these things about it because there's no energy low enough for us, small enough for us to hit these small energetic things. So we can't hit them with anything small enough. They're so small we can't shoot photons at them. We can't shoot anything at them because whatever we shoot at them is going to completely change who they are and where they are. It's going to completely change the field that's deciding their fate. And so that's a fact. And he just said it's not because. Well, clearly it could be because. But he pretended that that's not the reason. That can't be the right answer. No, that can be the simple right answer. We can't see them. That's why it's uncertain.
This is a fundamental property of the universe.
It's just a statement. Just it's part of their religion. God is God. You must believe. We believe, so you should believe. It's a religion. There's no evidence. There's absolutely no good reason for you to believe this crap.
And finally, where does the name quantum come from? Well, a quanta is a packet of something.
There you go. So why are you pretending it's this wave crap? Waves aren't packets, frankly. It's too silly even a statement to even acknowledge as having any meaning. It's so stupid.
Like a chunk of something. And one of the first quantum effects people saw were atomic spectra, which is where atoms give off light with specific discrete energies.
Right, and that's all just about where the electron is in the atom will say how fast the electron's going to move. If it's going to get jolted out of its position, it has to be jolted by a certain amount of energy. That means a lot of energy has to jolt it out of being tight. So if it was like gravity, you want to knock something out of its orbit. You have to apply more energy to knock something that's closer to the sun out of its orbit. Just a fact. It's going to require more energy because it's more tightly bound. All right. So and that's all this is a reflection of. You want to knock Mercury to the Earth's orbit, and then you want to knock the Earth to Uranus's orbit. Those take different amounts of energy, and it takes a lot less energy to knock the Earth into Uranus than it takes to knock Mercury into the Earth, kind of thing, orbits. And that's all these different colors are a reflection of, that there's certain real amounts of energy that you have to apply, and when you apply that much energy to move Mercury out of its orbit, it means Mercury's going to move faster getting to the Earth's orbit than the Earth is going to move getting to Uranus's orbit. The Earth will go a lot slower than Mercury will go because you have to apply more energy to get it out. That's the argument.
It works like this. Imagine a string that's tied at both ends, like a guitar string. If you pluck it, only certain waves can exist.
I think it's better to imagine what I just imagined. Frankly, this is just woo wah wah woo wah wah. We want to play a song of the universe. Woo 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 woo. Jesus, Jesus, woo woo.
Because the ends are tied down. In this situation, we say that the wavelengths are quantized to certain values.
Yeah, it's just silly. It's just quantized by this lumpy crap has something to do with quantizing something. Ugh, forget it.
The same thing happens if you tie the ends of the string together because the waves have to match up.
Well, now it's string theory.
They can only vibrate in certain restricted ways. And this is what's happening to an electron in an...
Says you, with no evidence. You just made this up as a silly little gremlin story explaining why, hey, there's more left socks in my drawer than right socks.
Atom. The electron wave is constrained by the atom and quantized to certain wavelengths. Short wavelengths have got a high energy and long wavelengths have a lower energy.
Well, again, see, this is, again, just about resonance. So you're really just saying what are you pushing on depends on whether you're going to add or subtract. So if I have a big, slow pendulum, I don't want to be hitting it with a high frequency because I'm going to be hitting it the wrong way half the time. But if I hit it with a slow frequency, I can add energy to the big pendulum. Where if I add the energy at a high frequency, completely ineffective. But I add it at a slow frequency, then I can make the pendulum swing more and more and knock a building down. So this doesn't have anything to do with the real effect of stuff. This stupid presuming frequency to be momentum. Frequency is not momentum. Momentum is just a raw measure, and if you're affecting a system, you have to always affect the system in a complementary way if you want to add energy to that system. If you don't do it that way, then yes, you'll essentially destroy your energy's effectiveness at adding energy. You'll just end up reflecting your energy.
This is why the light emitted by an atom looks like a barcode, because each bar of light corresponds to an electron jumping from a wave with a high energy to one with a lower energy.
So again, it just takes that much energy to move it, to break it free. It's just about the breaking energy. It's like how thick the string is, and how much energy, how much fire you have to use to burn the string. What kind of different analogies? A thicker rubber band takes more energy to break the rubber band. Therefore, when it breaks with more energy because it has more contractibility. It just has to do with how tight the spring is. Frankly, that's how it can be understood. You don't need any of this wavy crap to understand.
And at the same time emitting a quantized photon of light when it does this. So the light from an atom...
So the emission part is just the movement of the electron. And clearly one electron cannot make hugely polarized light. So clearly when you see light, it's not coming from one electron. It has to come from a group of electrons connected into a group of atoms. It's again a group behavior that they've misunderstood, okay, as some sort of individual behavior.
Is quantized to discrete packets of energy. Okay, so that's all the basics of quantum physics. Here are some technical notes which aren't essential to know, but pause the screen now if you're interested in a little bit more mathematical detail.
Yes, mush.
So to round up, in quantum physics, objects are described with wave functions, but when we measure them, what we see are particles. So this leads to particle-wave duality.
Which is all mush and silly and retarded, and anybody should just say, your theory's incomplete. There's something wrong because you shouldn't have to go in those wacky directions.
Also the measurement problem. And the consequence of these wave functions are the quantum phenomena of superposition, entanglement.
So again, this is just them forcing individual objects to be the group. And an individual isn't the group. And the group is decided by a whole bunch of variables, and the individual is obviously decided by much fewer variables. And the variables are going to be how close to the slit were you when you went through the double slit. That's going to be one of the variables that are going to decide where you're going. That's the simple answer. They want to make it something else. They want to make that simple answer into some wooey BS. Some stupid, ugly, smelly, junky, cruddy religion. And you people seem to just want to go along. You'll keep rewarding it. Give them more money. Fill their Patreon pockets. Oh, they're doing science on the internet. It's bad science. It's an insult to our intelligence. If you had any intelligence, you could recognize that. I mean, you're obviously all the dupes. I mean, what can I say? You're all so dupable. Why are you believing this crap? Ugh. Alright, anyway. Oh, I forgot to move my arrow. Oh, sorry about that. There's always some kind of defect because I'm not truly a professional. Anyway, till the next time and such and so forth and whatnot. All I can do is reason with you. That's all I can do. You have to do the other side of being reasonable. Yeah. And apparently not very many of you are capable.